With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. In this video, we have a question that a resting axonal membrane is comparatively more permeable to and nearly impermeable to. So here options are in the form of sodium ions, potassium ion, calcium ions are provided. Okay. Basically, we know that there is a main thing we have to understand, that is the permeability and impermeability. Okay. So let's understand this. So there will be some ions present. So at the outside, that is the outer fluid, there will be some positive plus ions, and on inside, if you observe, there will be negative charge will be there. Correct? Negative charge toward inside and positive charge outside. So there will be the flow of sodium and potassium. Basically, the sodium which is present in the outer fluid. Okay, here there is outer fluid and sodium is present here. Correct? Na plus. So this sodium basically cannot travel inside. Why? Because the sodium flow is restricted. The sodium flow is not, like sodium is not allowed to come inside. That is restricted. But if we take about the K plus, that is potassium, then the potassium flow inside is very high. Potassium flow inside is high. And if you observe, the potassium amount at the outside is low. Okay. So potassium concentration or potassium will be low at the outer side, because potassium is very goodly permeable. Potassium is very nicely permeable to go inside. So more potassium concentration will be there inside, and less sodium concentration or nearly no concentration of sodium outside, because it is nearly to impermeable. It is not like that there will be no sodium ions inside. Obviously, there will be some flow of sodium ions, but that is very low. So, if we compare the permeability of both of them, so here we will write the permeability of both of them. Sorry, it should be permeability. So, there is a different permeability of sodium and potassium. So, how is that? So, permeability of sodium, if we taking potassium, then it is 100 times more than the sodium. Understand? So if we took the permeability, and that is the permeability of potassium is 100 times more than the sodium. Simple. So that's why here you can observe that the flow inside the axonal membrane, the potential which is created at that membrane, axonal membrane. So at that place, the potassium flow is more good and permeable than if we compare the sodium. Okay, and this is a resting membrane potential basically. That is also main thing to understand. This is a resting membrane potential, because in the question it is already provided potential. The question is already saying that it is the resting axonal membrane. That means the resting potential will be created there. And we know that the value of resting potential is like nearly to be minus 70 MV. Okay. So minus 70 is the most, like microvolt will be there. But if some neurons are longer than the usual, then it can nearly go to the 90 also value, like minus 90 microvolt. But mostly the value which is considered, that is 70. Okay. So this is the resting membrane potential, that is we can say RMP. So basically this is the RMP normal condition it is being provided, and here we understand that which of the permeable and which is non-permeable or impermeable. So that's why here in which option it is provided, that permeable to potassium ions and impermeable to sodium, that is being provided here in the second option. That's why here our answer will be option number 2. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.